Okay, how do we evaluate trig ratios for any angle? Well, let's talk about the trig ratios that we already know for right triangles. The sine of theta with SOHCAHTOA, sine is the opposite over the hypotenuse. Cosine of theta is the adjacent over the hypotenuse. I'm having a hard time writing my y's today. And the and the tangent of theta is the opposite over the adjacent. So today we're going to introduce the cosecant, the secant, and the cotangent. And these are just the reciprocals of sine, cosine, and tangent. So cosecant is the reciprocal of sine. So it's 1 over the sine of theta. Or if you think just reciprocal, you just flip the fraction. This is the hypotenuse divided by the opposite side of a right triangle. Cosine and secant are related. So the secant is 1 over cosine theta. So we just look back at cosine, adjacent over hypotenuse. Well, the secant is going to be the hypotenuse over the adjacent side. The cotangent is the reciprocal of tangent, so 1 over tan. So this is the adjacent side divided by the opposite side. Alright, now to find the trig ratios for any angle, you have to follow the 6 steps. Draw the terminal side, draw the reference angle. Once you have that, you can draw the right triangle, label the triangle. You'll have to use Pythagorean theorem, and then finally, once you check the signs, you'll be able to get all the ratios. So let's just look at an angle and how we would set up a right triangle from that. So I've got my terminal side drawn, and then this would be my reference angle, the angle that got me back to the x-axis. Okay, so this is the theta that we're going to be talking about. I can use this ray to draw a right triangle. And now, the point at the end of this angle is some x and y coordinate. Right? Well, to figure out how far out I go, that's the x. And the x is the adjacent side of that angle. So the x is the adjacent. The opposite of that angle, well, this tells me how high I go. This is the y. So this is the opposite. And now, if I were to spin this angle around the axis, I'd get a circle. So this has a radius, so we'll say this is r, and this is my hypotenuse. Okay, and one little note, the hypotenuse, what is going on with my y's? The hypotenuse is going to be positive all the time. All right, and then that last part where I say check the signs, that's just referring to the x and y axis. Right, so quadrant 1, 2, 3, 4. If I'm in quadrant 1, I have a positive x and a positive y. Quadrant 2, you have a negative x and a positive y. 3 would be negative, negative. And 4, you have a positive x and a negative y. All right. We're going to find all the trig ratios given the point 13, negative 4. So this point is at the end of my ray. So that's positive, negative, right? Positive 13, negative 4. So I know that it's in quadrant 4. I've gone out 13 in the x direction and down 4 in the y. So I make my right triangle. There's theta. Before I can do all my ratios, I'm going to have to figure out what the radius is by just figuring out the hypotenuse. To figure out the hypotenuse of a right triangle with two sides, I use the Pythagorean theorem. So,
do you just use the absolute value?
Alright, so r squared equals 13 squared plus negative 4 squared. So r squared is equal to 169 plus 16 is 185. So the r is equal to the square root of 185. And we could simplify this radical, but for right now we'll just leave that. Okay, so now that I've got all three sides of my triangle, I can set up my trig ratios. I'm going to start with sine, cosine, and tangent. So sine theta is the opposite over the hypotenuse. So that'd be negative 4 over the hypotenuse of square root of 185. Again, this is like you can't leave a radical in the denominator, but since we're just setting up the ratios, we'll leave it like this for right now. The cosine of theta is the adjacent over the hypotenuse, so 13 over the square root of 185. And the tangent of theta is the opposite over the adjacent. Okay. Now, for our new ratios, we have cosecant. Well, remember, cosecant is just the reciprocal of sine, so you just flip that ratio. The cosecant of theta would be the square root of 185 over negative 4. The secant of theta would be the square root of 185 over 13. And the cotangent of theta would be 13 over negative 4. Okay, in the last example we were given a point and told to find all the ratios. This time we're given one of the ratios, and we have to find all the rest of them. So if I give you if you're given a ratio, you have to know what quadrant you're in. So here it says whenever 180 degrees is less than theta, and theta is less than 270 degrees. So that lets me know that, yeah, I'm in quadrant 3. So whenever I go set up my triangle, I'm going to set it up in quadrant 3. Here's my little theta. Alright. Now, cosecant's related to sine. Sine is opposite over hypotenuse, so the cosecant is the hypotenuse over the opposite. Now earlier, we talked about how the hypotenuse is always positive. So if this is 7, then the opposite must be negative 3. And it should make sense that the 3 should be negative because we're in quadrant 3, so the y is a negative, right? Because it's below the x-axis. So now I need to find this x, the adjacent side. So I set up Pythagorean theorem, 7 squared equals negative 3 squared plus x squared. And 49 is equal to 9 plus x squared. So the square root of 40 will equal x after subtracting 9 and taking the square root. And I'm going to go ahead and reduce that. 4 goes into 40, so I can pull out a 2. 2 square roots of 10 equals x. Now here, since I found an x, I have to be careful. Anytime you find x or y, you have to be careful to check the signs. Since I'm in quadrant 3, I'm on the left of the y-axis, so all of my x's are negative. So this needs to be a negative 2 square roots of 10. Negative 2 root 10. Alright, now I have all the information I need to find all the ratios. The sine of theta. Well, the sine is just the reciprocal of cosecant, so negative 3 over 7. Cosine of theta be the adjacent negative 2 square roots of 10 over 7. And the tangent of theta is the opposite over the adjacent. Now since both of them are negative, this turns into positive 3 over 2 root 10. We were already given cosecant, so we can jump to secant of theta. Well, it's the reciprocal, so negative 7 over 2 square roots of 10. And the cotangent of theta would be 2 square roots of 10 over 3. Now, once I have all of my trig ratios, I'm done.